Hello Year 12 and welcome to our fourth video here for our topic on networks. Today we're going to look at shortest path problems. So we're just going to try to find on a weighted graph the shortest distance from, start to finish, from A to B or whatever. So we might just do that by inspection, trial and error. We go, what about this way? No, not that way. This way looks better. Is that better? Yes, it is. Sometimes that's the most efficient way, really, than setting some structure up. So here's an example. We want to find the shortest path from A to F. Let's have a look. Well, I could go straight from A to C, or I could go via B. Now, if I went A to C, it's 4. But if I go via B, 1 and 2, that's only 3. Okay, so that's a good start there. Now, I've got no choice. I'm going to have to go this way. That's going to be part of my shortest path. Now, we're trying to get to F. I could go directly there in 8, or I could go via E, and that will be 9. So I'm better off going this way. Rightio? So that's my shortest path. The length of, so my shortest path, write that down. The shortest path is A, B, C, D, F, with a length of, or a weight, we should say. It's not necessarily a length. With a weight of, yeah, it's 1 plus 2 is 3, plus 5 is 8, plus 8 is 16. Okay, that's the shortest path from A to F. There are a number of other paths. I think there's probably, we could come up with 3 other paths, but 16 will be the one with the smallest weight. So for really simple networks like that, well, that's fine. But as they get longer, they get more complicated. And while that really only had about 4 paths, potential paths from A to B, right? If we have a look here in example 9, we're trying to get from A to E. There are many more ways to get there. So we need a bit more of a strategy to find the shortest path in a fairly efficient way. What we're going to do here is we draw the graph with these open circles instead of closed dots, because I'm going to write numbers in there. And in fact, that's going to be the shortest distance to that vertex. So I'm going to start, you can read those instructions there, but I'm going to start from A and look at everything that I can get to in one step, right? That's one edge away. So I don't really need anything here, because from A to A is obviously 0. But from A to B, I could get there in 3. Right? That's the best way to get from A to B. It will take me 3. To get from A to G, the best way to get there is going to take 4. Now to get from A to C, I could get there in 7, but I could go 3, 2, I could get there in a 5, 4, 2 is 6. So in fact, the shortest path from A to C is a 5, right, going that way, via B. Now let's look at everything that's 2 steps, at least 2 steps away from A. So, or a minimum of 2 steps from A. So I could go this way, right, to F. In fact, to get to F, I'm going to come from C or from G. Now it's 5 steps from C and then 3, or 4 from G and 3. So the best way to get to F, the shortest distance from A to F is 7. The shortest distance to D, right, I could get there via B in 7 this way or 9 that way. So if I go 7 this way, oh wait, no, we shouldn't look at it that way. I could get there along here, along this edge, that will be 12. Or I could get there from C. Now the shortest distance to C is 5. So 5 plus 6 equals 11. So the best way to D is an 11. The best way to get to D is 11 from C plus another 6. Now to get to E, I'm nearly there. It could be 5 and 10 is 15. It could be 11 and 4 is 15. Or it could be 7 and 7 is 14. Okay, so that's my best way there. Now we'll just trace backwards to see what that path was. Right, to get that 14, I came by here. To get to that 7, I came along from G, and to get that 4, I came this way here. So that's my shortest path as AGFE with a weight of 14. Okay. We saw there were a number of other ways to get there, and some that were close. There were a few 15s, but that was the shortest path. Rightio, well that's it for finding the shortest path. Remember, draw those open circles, right, and progressively work your way from basically left to right, from one end to the next, by finding the shortest distance to each of those places along the way, right? The shortest distance to each of those vertices on your way to the end, right? And that should minimize the number of trials and error that you have to work through. Okay, well, that's it for shortest path. If you've got any questions, jot them down. See you in class.